Hello, dear student. Good morning. So today we are going to discuss on the mass multiplication of microbial pesticide. It is the part of integrated pest management, but actually it's a one topic related to biopesticide. So as we know that in field the many pests that attacking on crops, and there that the farmers and other that some agency different companies that related to pesticide that are highly that more amount of that using synthetic biopesticide, synthetic pesticide, and which is very toxic to human, even also that other animals, non-targeted animals some predators, parasite, as well as human and animal. So actually in this biopesticide, it's a one pesticide also, but it is originated from biologically, by using of different microorganism where that evolved, and this microorganism like a virus, bacteria, some pheromones, and some of these compounds that are originated from plant and animal originated, and this compound together forming called as a biopesticide. And this biopesticide, it is not harming to human other beneficial organism because it is highly specific. Suppose the farmers want to control any one pest. Okay, so where this type of the biological pesticide that very effectively that to minimize and to control and to get result. Okay, so now while but chemical pesticide, which is the broad spectrum their ability, which is having very residual chances where that to found, even also which is very affected to non-target organism, including where birds like predators, parasite, honeybees, even also as well as humans, where due to the pesticide residue, which will harm in future that to causing the many hazards by using chemical pesticide. Okay, so this is the point related to chemical pesticide, and it is also the, if we consider, if we recommend the only biopesticide, so here this very effectively that having the environmental friendliness, even also the easy biodegradability that having, even also it is the one major tool in case of integrated pest management program, and which is greatly decrease the use of chemical pesticide. Okay, and in terms of the production and commercialization, these biopesticides have a low research expenditure, and even also the faster rate of product development, as well as the flexible registration process. That's where there is some lacuna, and to not that there is the proper awareness in the farmers, and even, but nowadays we know that many toxic hazardous that found earlier. So by to overcoming of this problem, so it's a best solution by using this biopesticide. Okay, now let's see in detail which are these factors affect that growth of biopesticide. So the factors which we have the restricted the growth of biopesticide are that having reliability because of the low stability in the effect. Okay, and even having the target specificity, and which distract the farmers, that's why the farmers not that using by this pesticide. Even also that having the chances of that get result is very slow, and if we compare with the other synthetic compound chemical pesticide, it's not getting the earlier result, that means the slow in action, that having the short shelf life as compared to other pesticide, that having erratic ability of biopesticide in the market, already established and strong market of chemical pesticide, so it is very difficult to that to fastly that by adopt this biopesticide in farmers. So there is the necessity to create awareness in pesticide of biopesticide in the farmers point of view. So even having regulatory system favorable to chemical pesticide than biopesticide, and the gradual disappearance of multiple mixed cropping, and which is known to keep away the magic bullet chemical pesticide. Okay, so dear all students, this is all are the factors which are affecting the growth of biopesticide. That's why there is the problem in the farmers and those are company related to biopesticide. It is not easily that to adopt it and that to use in the farmers. Okay, but as if you think about the organic farming, so this is the best solution to keep the pest level in the at certain level, and even also that to using this biopesticide to we can minimize the pesticide residue and further resistance and like a resurgence whenever that occurred by this pest. So this is the best solution if you use by this biopesticide. So now in this in India, the status of this biopesticide are only 2.89% as on if we see in the 2005. The overall pesticide market in India, and which is expected to exhibit an annual growth rate of about 2.3% in the coming years. This is the reference, okay, about the pesticide in India. In India, only 12 types of pesticide that have been till registered under the Insecticide Act by in the year 1968, and some of this botanical pesticide like neem-based pesticide, even Bacillus thuringiensis, that is bacteria, some of the viral biopesticide NPV, some fungal, that is a trichoderma, are the major biopesticide produced and using in India to many diseases and the pest. Most of the biopesticide find use in the public health, and except a few that are used in the agriculture. Like some of these other technology, if we consider like transgenic plant, this is the also the good solution to minimize the pest by using the resistant plant, and to those pests are overcome. Okay, that those pests are that highly destructive, that to remove this pest by using this transgenic plant where use some beneficial organism like called as bioagents or natural enemies are used in the pest management in India, and consumption of pesticide or pesticide has increased from 219 metric tons to 683 metric tons, and consumption of chemical pesticide, as it is seen in the significantly fallen from this 56,114 metric ton to 43,584 metric ton during the same period of, if we see this whole that using or this consumption point of view, this is the overall like some information regarding. So some of these pesticide till they are the registered and used to minimize the pest by even also that to controlling the various diseases like a beauty, that Israelensis, Kostaki, Gallery, like even some sphericus, Trichoderma viridi, Trichoderma arzeneum, Pseudomonas fluorescens, Vivaria bassiana, some NPV, Helicoverpa armicera, some NPV of Subroptera litura, neem-based pesticide, and these syngopogan. These are the 12 types of pesticide used in India till date. So these are the some like some information related to pesticide. So what is the mass production of nuclear polyhydrosis virus? So in exam, we'll ask that the HNPV virus and its procedure, it's very important to how to that prepare, what is the procedure that required where that HNPV that to production where occur, and it's a procedure of mass production of HNPV. So firstly, the HNPV means what? Helicobacter nuclear polyhydrosis virus, that is HNPV, and this HNPV is commonly used against the gram pod borer, American bollworm, Tur pod borer, and tomato fruit borer. These are the very severe pests, and which is known as a polyphagous pest that commonly that is scientific name of Helicoverpa armigera, isn't it? This Helicoverpa armigera, which is highly destructive pest. That's why this pest, if we want to control, so here that to get the best result by using this HNPV. So it is a cosmopolitan, highly destructive pest that not only require only one host, they are that ability to that use alternate host like various crops and even some grasses also, some alternate host having also. So that's why its chances of survival is more in the open field. If you seen in the annually loss in India, so more than over like 1,500 crores per year. It's not a like a joke. It's a very severe pest that it's a crosses that more infestation than the ETL. Most of the insecticide fails to check the pest or to minimize the pest, even to control the pest. But if we consider about the biopesticide of this HNPV, that to got the best result. So that's why, because of there is the development of registers of in this Helicoverpa parvicera to this many chemical pesticide. So it's not only to solution to use only chemical, that's what is required to NPV. And it is proved that to give the if the farmers want these long term that prevention or protection to against this pest, only the HNPV is the best solution to minimize and to control this pest. So let's see in detail about its the procedure or different steps were involved in the mass production of HNPV. So firstly, that require mass culture of host insect of हेलिकोर पार्मिजरा. बरोबर, त्याचं एक मास कल्चर आपल्याला गरजेचं आहे, जेणेकरून आपण त्याचं लॅबोरेटरीमध्ये आपण त्याचं मास प्रोडक्शन करू. पहिल्यांदा काय करायचं, फर्स्ट स्टेप यू हॅव टू नीड टू कलेक्ट द लार्वा ऑफ हेलिकोर पार्मिजरा from the field if available there. So if we get, then immediately we can collect it and rear them individually in a plastic bottle. त्याला आणायचं आपल्या लॅबमध्ये आणि त्याला आपल्या लॅबोरेटरीमध्ये प्रयोगशाळेमध्ये त्या प्लास्टिक बॉटल्समध्ये त्याला इंडिव्हिज्युअली रेअर करायचं. इंडिव्हिज्युअली रेअर करण्यामागचं कारण हे की देर इज अ चान्सेस टू कॅनॅबलिझम, ते एकमेकांना खाऊ शकतात. So that's why to avoiding of this cannibalism, it's the best that to require the plastic bottles and to rear individually. Now, after the full-grown larvae, it's a this full-grown larvae going or that to undergoes to the pupation, and then after the pupa in the sawdust or this fine soil that kept in a that kept in the wooden cage. After a week, starting this pupa to adult emerging, collect them the प्रौढला adultला कलेक्ट करायचं and then introduce in a OE position cage. एका OE position cage मध्ये त्या सर्व adultsला आपल्याला ट्रान्सफर करायचा आहे. Because why? There we need the more quantity, that lot of quantity required the eggs of this Helicoverpa armigera. Then will that possible to production of HNP. And this wooden cage required to prepared by wrapping black cloth the piece around the wire cylindrical frame of the soy position cage. After 2 days, remove the cloth along with the eggs of Helicoverpa parmigera, because this that black cloth is totally filled that covered with the eggs laying takes place on this cloth, and this cloth will that to collect it and keep this cloth with the eggs in the plastic jar for the incubation. त्याच्यानंतर जो क्लॉथ आपण ब्लॅक क्लॉथ त्या ओई पोझिशन केज मध्ये ठेवला होता त्याला कलेक्ट करायचं आणि त्याला एका प्लास्टिक जारमध्ये आपल्याला हॅचिंगसाठी त्या इन्क्युबेशन चेंबरमध्ये त्याला ठेवायचं. आफ्टर द फ्यू डेज द न्यूली इमर्ज लार्वा नीड टू कलेक्ट, ज्यामध्ये निघणाऱ्या ज्या नवीन लार्वा आहेत त्या अळ्या त्या आपल्याला कलेक्ट करायच्या आहे आणि त्याला परत त्या लार्वाला रेअर्ड इन द प्लास्टिक ट्रे अप टू दी 3 to 4 days फॉर द मास कल्चरिंग. आपल्याला अति प्रमाणात त्याचं संगोपन करायचं आहे. त्याचे खूप सारे लार्वा आपल्याला त्याचं रेअर करायचं आहे. त्यासाठी त्या कलेक्ट करायच्या आणि त्यांना मास कल्चरिंग 3 to 4 days पर्यंत त्यांना त्यांचं रेअरिंग करायचं. आफ्टर द लार्वा नीड टू सेपरेट इज that already I talked to you previously, that kept in the individual small plastic bottle. Why? Because of to avoid cannibalism. Provide them a piece of artificial diet. But in this laboratory, it's not possible to give the natural diet So that's why we need some like different artificial diet for feeding purpose. Now, which are this the procedure of preparation of artificial diet? So firstly, here the three part involved to preparation purpose of artificial diet. In first part, required some ingredients. Firstly, gram flour we need at the rate of 140 gram. Need yeast powder 13 gram, formaldehyde 2 ml, distilled water 400 ml. Now, in second part, need some ascorbic acid like a 4.3 gram, methyl parabenzoate 2.6 uh, of sorbic acid, 1.6 gram of multivitamin capsule, and 0.3 gram of streptomycin sulfate of 0.3 gram. So this is the second part requirement of this HNPV virus. Okay, so now third step, part of 3, agar agar 17 gram, distilled water 450 ml. Okay, so now which is the what is the procedure required to preparation of artificial diet? Firstly, in this part 3, agar agar 17 gram, distilled water 450 ml. So first mix the part 2 in part 1. आपल्याला काय करायचं, हा पार्ट 2 ला पार्ट 1 मध्ये मिक्स करण्याची गरज आहे. आफ्टर third part requirement that to warming third part up to 7 degrees Celsius, 70 degrees Celsius, and what already we previously that the part 1 and part 2 mixing or mixture. So this adding, okay, we have to mix together of part 3 and part 1 and 2. After warm whole mixture until the steam starts, जोपर्यंत वाफ निघणार नाही तोपर्यंत ते आपल्याला ते पूर्ण पार्ट जे एकत्र केलेलं आहे ते आपल्याला एकत्र पूर्ण त्याला मिक्सचर करून त्याचं वार्म करायचं. आफ्टर pour this semi solid diet in aluminum trays, what may be the final product we got, that to mixture of these three parts that we have to put in the that pour in the aluminum trays and need to allow it to cool. And why cooling? Because we need artificial diet to its pieces, and this cut the pieces of the semi-solid food of 1 into 1 centimeter like that to cut it, and this piece of each each food of this artificial diet that required to that for the our newborn larvae in the laboratory. So now what is the procedure of propagation? Now here that actual protocol, how to propagate, how to contaminate, how to production of this HNPV. Firstly, after those larvae be reared in the laboratory, selected. So the selection, how to select, there is the instar larvae need. The third and post instar larvae very important. That initial stage after first, second, and then third and fourth instar larvae. This third and fourth very effectively that will get more number of that our biopesticide. Pre-stall this, त्यांना थोडंसं भुकेलं ठेवायचं, pre-stall करायचं this larvae and need that pre-starvation of hours 6 to 8 hours. After this 6 to 8 hours, so already our like that we have that prepared artificial diet, we have to need to contaminate the virus of HNPV with the brush. ब्रशच्या साहाय्याने जो आपल्याकडे व्हायरस अवेलेबल असेल that we got from this naturally, otherwise that got from this different agency where that actual production occur by this HNPV. So we just to smear this small quantity of this HNPV virus on that prepared artificial diet. After this contaminated food of this, introduce a piece of contaminated diet in each plastic vault where already this larva were that kept for feeding, and these larvae are already pre-starved. So this after the ingestion of this virus that starting the feeding, so there is the ingest virus and the larva begin to showing the symptoms of व्हायरल डिसीजेस. त्याच्यामध्ये आपल्याला जो काही आपला तो व्हायरस आपण त्याला कॉन्टॅमिनेट केलेला होता या फूडमध्ये बघा, फूडमध्ये तो खाल्ल्यानंतर ती लार्वी 4 ते 5 दिवसामध्ये एक व्हायरसचं स्वतःचं एक सिम्पटम दाखवायला सुरुवात होईल अँड स्टार्ट डाईंग. 6 ते 7 दिवसामध्ये ते killed while a start. This dead larva you have to collect it, and this collect it. How to collect? Because this larva that's showing one to emit brownish black viral ooze on स्लाइट प्रेसिंग. जेव्हा आपण ती लार्वा जर आपण थोडीशी जर प्रेस केलं तर त्याच्यातून अशा प्रकारचा एक द्रव बाहेर निघतो, तो म्हणजे कुठला ब्राउनिश ब्लॅक व्हायरल उजाव. And then we that considered it's a ready to collection or to production of this HNPV. Collect this is larvae, and in this put in the distilled water, and their need putrefaction for 10 days. त्याला putrefaction साठी 10 दिवसाकरिता त्याला ठेवून द्यायचं. Now, after this putrefaction, filter this suspension and centrifuge for 3 to 4 minutes of at 500 RPM speed through the centrifuge machine. Nantar, what may be the pellets settled in the bottom and may be discarded, and to collect supernatant is again centrifuged at the 2500 RPM for the 10 minutes. After here, the supernatant is discarded and the pellets were settled at the bottom may be used by mixing 10 times of water in it. त्याच्यामध्ये थोडं वेगळं आहे, ते थोडं रीड करा आणि त्याबद्दलचं थोडंसं अंडरस्टँडिंग करूनच ते वाक्य तुम्ही लक्षात ठेवा. आफ्टर सुपरनंट हिअर डिस्कार्ड, but maybe the pellets settle in the bottom. So these pellets that we use for the by adding of distilled water 10 times, then this suspension is ready to HNPV that to further using. Okay, after the strength of here the polyocclusion bodies where we have to need to count it and suspended in unit water counted by using the microscope and hemocytometer, and after the calculating of this POBs, this polyhedral inclusion bodies or this polyhedral occlusion bodies, then there is required of this each ml or each solution of this whenever we count under the microscope or hemocytometer, that to count required is 1 into 10⁹ POBs per ml, and then further so dilute it the suspension as per the need accordingly that using the pest management. So dear all students, this is the whole procedure of to how to production done the HNPV virus in the laboratory for the minimizing of Helicoverpa armigera or Helicoverpa armigera pest on the different crop. So this is very important topic. Thank you.